So for topic 4, we're going to take everything we've learned so far about graphing quadratics and just put it all together, okay? So really quick, just as a kind of a gentle reminder, we're going to look at a general strategy or basic steps that we can take to solve quadratic equations. So please do remember that you can have a parabola that opens up. This occurs when a is greater than 0, so think a is positive, smiley face, and this type of parabola has a minimum point. So the vertex is like the lowest point on the graph. If you have a parabola that looks like this, we would say it opens down. This occurs when a is negative, so think negative frowny face. And this type of parabola has a maximum point. So when we find the vertex, it's going to be the highest point on the graph, okay? So the first thing we want to do when we go to graph quadratic equations is determine if the parabola opens up, like what we have here, or if it opens down, like we have here. It's just nice to kind of get a vision in our head of what our parabola should look like. So determine if it opens up or down. You then need to find the vertex, the x-intercepts, and the y-intercepts. And it does not matter the order you find these in, just make sure you find them all. And then once you have all of those points, we want to plot these points and then connect it with a parabola. We're not going to look at super, super crazy difficult examples. We'll save that for pre-calculus. We want you to just understand the basics, the foundation of how all of this works, so that when you see those more complicated examples in pre-calculus, it won't be quite so daunting. Okay? So it says example 4 here, graph each quadratic equation using the strategy outlined above. So the first thing we're going to do is find the vertex, the x-intercepts, the y-intercepts, all of that stuff. Then we'll go and graph it, and then we'll just compare notes with what we see in Desmos. Okay? So for part A, we have y equals x squared minus 2x plus, or let's see, x squared minus 2x minus 8. So does this parabola open up or down? This one happens to open up. A is equal to 1, which is positive. So that means we're going to have like the smiley face parabola. So it opens up, and that type of parabola has a minimum. So when we find the vertex, it's going to be the lowest point on the graph. Okay? Now we're going to need to know what A and B are in order to find the vertex. So A is 1, B is -2. Let me write that a little bit better. Now remember, to find the vertex, we let x equal -b over 2a. Well, -b just refers to the opposite of b. So since b is -2, we're going to plug +2 into the formula. So we're going to get 2 divided by 2a. Well, a is 1. So we get 2 divided by 2, or 1. So far, my vertex has an x-coordinate of 1. Now we need to plug that x-coordinate of 1 back into the quadratic equation and solve for y. So y equals 1 squared minus 2 times 1 minus 8. So let's see, 1 squared is 1. -2 times 1 is -2. Move over our -8. So 1 minus 2 is -1. -1 minus 8 is -9. So our vertex is the ordered pair 1, -9. So that's our vertex. Now, to find the x-intercepts, we want to solve, okay? Now, for the sake of space, I think I'm going to do this over here on the side, and then we'll come back to this area where I have, alleged room to find the x-intercepts. So we have y equals x squared minus 2x minus 8. To find the x-intercepts, we always let y equal 0. So we get 0 equals x squared minus 2x minus 8. So we now have standard form. This is a quadratic trinomial. It looks to be factorable, so let's see. We have a quadratic trinomial where a is 1. That means we can jump straight to that shortcut where we have two binomials. Now we need factors of -8. That means one positive, one negative, that have a sum of -2. So we could use -8 and 1, 8 and -1. -4 and 2, or 4 and -2. So which of those 4 pairs of factors has the correct sum? They all have a product of -8, but which pair adds to -2? Well, this pair right here. So that tells me I have x minus 4, x plus 2. So let's scroll down just a little bit. Okay, so now I have a product equaling 0, so I apply the zero product principle. So I take each factor and set it equal to 0. Well, for the first factor, I would add 4 to both sides. That tells me that x equals 4. For the second factor, I would subtract 2 from both sides. And that tells me x is -2. So the actual x-intercepts are the ordered pairs 4 for x, 0 for y, and -2 for x, 0 for y. So those are the x-intercepts. Now the y-intercept is pretty easy to find. We let x equal 0 and then we solve for y. So I get y equals 0 squared minus 2 times 0 minus 8. Well, 0 squared is 0. -2 times 0 is 0. 0 minus 0 minus 8 is -8. So the y-intercept is 0 for x, -8 for y. So that's my y-intercept. So now what I want to do is I want to take all of those points and I want to plot them individually. So we know that this opens up. Now let's plot the vertex, which is the ordered pair 1, -9. So at the origin, I'll plot the actual points in red just so they're really easy to see. At the origin, we go to the right 1 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We've got x-intercepts of 4, 0, and -2, 0. So at the origin, I go to the right 1, 2, 3, 4, and then I stay there. At the origin, I go to the left 1, 2, and I stay there. Okay. Now for the y-intercept, we have the ordered pair 0, -8. So that means at the origin, I don't go left or right, but I do go down 8. So that's going to be right here. Okay. Now, if I can connect these 4 points with a parabola, I have my graph. Okay. So we're going to try to do this nice and pretty. Anytime you do it by hand, it's going to have a little bit of an imperfection to it, but we try. So there is our parabola. So remember these important points. We have the vertex, the x-intercepts, we have the y-intercept. We can see that this opens up. If we were going to look at the axis of symmetry, which at this point I'm not too bent out of shape about you knowing it, it will come up when you get to 171 or pre-calculus. So the axis of symmetry is the vertical line that goes through the vertex. So we want a vertical line. That means it has to be x equals a number. And the only the only x coordinate we have for the vertex is 1. So the axis of symmetry is x equals 1. So that would be this point, or not this point, but this vertical line right here. That's your axis of symmetry. Okay, now let's jump over to Desmos and just see if everything matches up. Remember, Desmos is a fantastic tool, but don't overuse it. You still have to duplicate these steps and understand this process in class, okay? So let's see what Desmos says. Now our equation was y equals x squared minus 2x minus 8. Well, that looks pretty much like what we had. I need to scroll down a little bit. So you can see that our x-intercepts are at the point -2, 0, 4, 0. Our vertex is the point -1, -9, and our y-intercept is the point 0, -8. So we can verify all of those really important points here. And if you want to see the axis of symmetry, just for the sake of kind of understanding, we decided the axis of symmetry was x equals 1. And sure enough, there we have it. That's the vertical line that goes right through the vertex. If we were to fold the parabola along this line, the two sides would match. Okay? So let's go back to the worksheet and do the second example. Okay, second example, we have y equals -x squared plus 2x plus 15. Because a is -1, this tells me that this parabola opens down. That means it's going to be like the little frowny face. Therefore, when we find the vertex, it's the highest point on the graph. So let's go ahead and do that. The vertex, remember, we let x equal -b over 2a. So let's figure out what a and b are. A is -1, b is 2. Now, when we have -b over 2a, we want the opposite of b. Since b is +2 here, in the formula, we're going to plug in -2. So we get -2 over 2 times a, which is -1. So I get -2 over -2, which is 1. So far, my vertex is the ordered pair 1, comma something. Now, to figure out what y is, we take this value for x and we just plug it back into the equation for y. Or we plug it into the equation for x and solve for y. So y equals negative 1 squared plus 2 times 1 plus 15. Well, 1 squared is 1, but remember, we have to multiply that by this negative 1 that was in front of the x squared. So we get negative 1 times 1, which is negative 1. 2 times 1 is 2, and then bring over your 15. So negative 1 plus 2 is 1, 1 plus 15 is 16. So our vertex is the point 1, comma 16. All right. Now let's see what we get for our x-intercepts. And just like before, I'm going to do the x-intercepts kind of over here to the side. Okay. So we had y equals negative x squared plus 2x plus 15. I'm going to go ahead and let y equal 0. That's how we find the x-intercept. So I get 0 equals negative x squared plus 2x plus 15. And remember, when we were solving quadratic equations, I always told you, hey, put this in standard form, but put it in standard form in such a way that the square term stays positive. I think it just makes it easier to solve when the square term is positive. So the only time you have to do this is when you're finding the x-intercepts. But I'm going to add x squared to both sides, subtract 2x from both sides, and subtract 15. Well, on the right-hand side, we're just going to get 0 because negative x squared plus x squared is 0. 2x minus 2x is 0. 15 minus 15 is 0. But on the left, we're going to get x squared minus 2x minus 15, and that equals 0. And now let's see if we can factor this. We always want to see if something is factorable because that's always going to be the easiest way to find your x-intercepts. If it's not factorable, then jump over to the quadratic formula. Okay? So let's see here. We've got a quadratic trinomial. The coefficient of the square term is 1, so we're looking for two binomials, both that start with an x. And we're looking for factors of negative 15, so one positive, one negative, and we want them to have a sum of negative 2. So we could try 15 and negative 1, or negative 15 and 1. We could try negative 5 and 3, or 5 and negative 3. So which of those pairs of factors adds up to negative 2? Well, this pair right here. So this tells me that we have x minus 5 and x plus 3. So now we have a product that equals 0. Okay, so we want to apply the zero product principle. We take each factor, set it equal to 0. For the first factor, we add 5 to both sides. So that tells me x is equal to 5. And then for the second factor, we have x plus 3 equals 0. So we subtract 3 from both sides. And that leaves me with x is negative 3. So for the x-intercepts, let's write them as ordered pairs. The first x-intercept is 5, so we get an x-coordinate of 5 and a y-coordinate of 0. And then the second x-intercept is negative 3, so our y-coordinate is negative 3, our y-coordinate, or our x-coordinate is negative 3, and our y-coordinate is 0. So those are our x-intercepts. Now for the y-intercept, we always let x equal 0. So we get y equals negative 0 squared plus 2 times 0 plus 15. Well, negative 1 times 0 squared is just 0. 2 times 0 is 0. And we add 15 to that. So the y-intercept is the ordered pair 0, 15. And now we graph it. So you probably can tell that we're going to have some slight issues graphing this because this is going to go way off of our graph. So what we'll do is we'll increment by 2. So each box will represent 2. Okay, that way we should be able to fit all of our points on the graph. So let's see, our vertex was 1, 16. So if each box represents 2, we'll go halfway to the middle box. And then we'll go down 16, which would be 8 boxes. So that's 1, and then that's negative 2. Wait, was it 116 or 1 negative 16? It was 116. Okay, so we'll go up. So we'll go to the right one, which is halfway over to that first box, and we're going to go up 2, 4, 6, 8, 10, 12, 14, and 16. So pretend that's that point right there, okay? Now the x-intercepts were 5, 0. So we go to the right 2, 4, and then halfway, which is 5. And then we have negative 3, 0. So at the origin, we go back 2, 3. And then our y-intercept is 0, 15. So we go up 2, 4, 6, 8, 10, 12, 14, and then halfway up is 15. So it's a little scrunched, but pretend So now we're going to graph this. Whoops. Maybe not the best parabola I've ever drawn, but I've certainly drawn worse. Okay, let's see. And there we have it. Okay, so if you were interested in the axis of symmetry, remember the axis of symmetry is the vertical line that goes through the vertex. So our vertex is the ordered pair 1, 16. So the axis of symmetry would be the vertical line. Vertical lines are x equals, and it would be x equals 1. So let's go to Desmos and see what we get. So make sure you've got this written down. If you need to pause the video, do so. And then we can meet at Desmos. Okay, we already have this junk here. We want to get rid of it so as not to confuse ourselves. So our equation this time was y equals negative x squared plus 2x plus 15. And let's zoom out. We can zoom in a little bit more. There we go. Okay, so let's look at the vertex. The vertex is the point 1, 16. The y-intercept is the point 0, 15. The x-intercepts are negative 3, 0 and 5, 0. So we can see all of those points we found algebraically are perfect. And now let's look at what we think the axis of symmetry is. It's y or x equals 1. And there you have it. If you fold your line along that bluish purple line, the two sides of the parabola would meet. So hopefully this wasn't too bad. Again, our goal in this class is not to give you the hardest examples. Our goal in this class is to build a foundation so that you will be successful when you get to pre-calculus. So this is just the basics, okay? Please do know that when you get to pre-calculus, you will probably look at more complicated examples of this, but this, again, is enough to build that foundation. Understand when parabolas open up or down. Understand what the vertex is, whether it's a max or a min. Understand how to find the vertex, know that you need to find the x and y intercepts, know how to find those, and then know ultimately how to graph that. And I'm not going to get too bent out of shape about the axis of symmetry, but it is an important part of this graph, so understand that as well.